Okay, let's do the problem set to discrete probability distributions, and then you can see that I have the Excel sheet open, and so we can double check the answers very quickly whenever we need the numerical solution. So let's begin. A multiple choice test has 30 questions. Each one has 5 possible answers, of which one is correct. If all answers were guesses, find the probability of getting exactly 4 correct answers. So that is the binomial distribution, obviously. And then we would say binom.dist, open parentheses, the number of successes. We want 4 answers right from a total of 30. The success probability is 1 divided by 5, and we want exactly 4 correct. So the answer is 0.25. Okay, multiple choices, 30 questions. So it's answer C. For 31/5. Okay, a total of 50 raffle tickets are sold for a contest to win a car. If you purchase 1 ticket, what are your odds against winning? Okay, so the odds ratio is defined as the probability of losing over the probability of winning, or it could be the other way around. And then the probability of losing is 49/50. The probability of winning is 1/50. So now the 50 cancels out and we get 49/1. But that should be a question that is that maybe should have been in a different topic. Okay, a process is characterized by the following. Only 2 mutually exclusive possible outcomes in each trial. So success or failures. The outcome in the series of trials are independent. Okay, so we know that one. The probability of success in each trial, denoted P, remains constant from trial to trial, so that the process is stationary. And of course, this is a Bernoulli experiment. Which Excel function computes hypergeometric probabilities? Okay, well, that's really very easy. It's obviously hypergeom.dist. So now a researcher needs 4 positive lab results with a probability where the probability is 0.3 each. Okay, what Excel formula gives you the probability that exactly 6 failures occur before the 4th success? Well, that's obviously the negative binomial, because the negative binomial is what's the probability that we have a certain number of failures before we get a certain number of successes. So we have 2 choices, it's either A or C. So 6 failures. Good thing is we can double check in Excel, neg binom.dist, open parentheses, number of failures, exactly 6, before we have 4 successes, when the success probability is 0.3. And again, the exactly calls for a non-cumulative estimation or calculation. So the answer would be 0.6 0.08, so roughly 8%. To find the cumulative probability that you get 3 or less events when the average number of events is 2, in Excel we would use which formula? So it asks for applying Poisson. Okay, so we would enter 3. The mean is 2, and then because we want it cumulatively, it would be true or 1. That would be 0.857, but what we entered is 3, 2, true. Okay, an email server receives spam at an average rate of 10 messages per hour. You want to find the probability of receiving at most 7 spam messages in the next hour. Which Excel formula is correct? So that's obviously the Poisson distribution. And it would be 7 occurrences when the average is 10, and the at most indicates we want the cumulative probability. Which of the following scenario is best modeled by the hypergeometric distribution? The number of 10 heads in 10 coin flips. No, that's the binomial. The number of accidents at an intersection per month, that's per time interval, that's Poisson. The number of women selected for a committee of 4 chosen from a group of 6 men and 4 women. Yeah, that's would be done by the hypergeometric distribution because it is drawing without replacement. The binomial distribution is characterized by situations that are analogous to drawing balls from a bowl. No, coin tossing, that would be it. Which of the following correctly describes the negative binomial distribution? Okay, so it has something to do with the failures. It counts the number of successes in n fixed trials? No. It counts the number of trials until the rth success occurs. That sounds right. It counts rare events over fixed time interval? No, that would be Poisson. And it doesn't count successes without replacement, so B is correct. The hypergeometric distribution differs from the binomial distribution primarily because the hypergeometric distribution only applies when p equals 0.5. No, that's nonsense. Sampling is done without replacement, so trials are not independent. That definitely is true. The hypergeometric distribution has no fixed number of trials. No, the hypergeometric distribution applies only to continuous data. No, it's a problem set on discrete probability, so B is the correct answer. A customer service center receives phone calls at an average rate of 3 calls per hour. Which probability distribution should be used to model the number of calls received in a given hour? And of course that's Poisson. To find the probability of getting 3 or less using the hypergeometric distribution in Excel with n equals 7, k is 10, and n is 30, you would set the cumulative argument to, so this would be an indicator for cumulative, so it's true. So we would write something like, what's the probability maybe should start with an equal sign. Okay, so the sample successes is 7. We draw 10. And actually, now we want 3 or less. When the sample is 7 and there are a total of 10 successes in the bowl and a 30. And now we have to say cumulative, so the correct answer would be 85%. A box contains 10 red and 15 blue marbles. If 6 marbles are drawn without replacement, okay, so that without replacement already tells you it has probably something to do with the hypergeometric. Which distribution models the number of red marbles drawn? And of course that's the hypergeometric. Which of the following is not a characteristic of the Poisson distribution? Events occur independently of each other? No. Like traffic accidents, they're pretty much independent. The average rate of occurrence is a constant, that's correct. We have a constant occurrence assumed. There is a fixed number of trials? No. Events are counted over a fixed interval. Okay. So D sounds right. Or which of the following is not a characteristic? So that is the fixed number of trials. So I didn't read that correctly. Oh, for a hypergeometric distribution with population 20, successes in population k equals 8 and a sample size of n. The mean number of successes in the sample is. Okay, that requires some formula. And I don't know the formula, but what I do know is that I can replicate the right result by simply working through that example. So we have a drawing and we want to draw 5. And when we draw 5, the number of successes in our drawing could be either 0, 1, 2, 3, 4, or 5. Okay, so now let's get the probability. So what's the probability that you get 0 successes when you draw from a population 5, where there are a total of 8 success elements in the bowl, and the total number of elements in the bowl is 20. So 12 are basically non-successes. And then I want it to be 0. So now I can calculate this and copy it down. And you can see that the sum of all those probabilities is 1. Okay, so now what is the average? Well, the average is the number of occurrences. So now I need to basically calculate the probability times the number of successes. Okay, so I do equals 0 times the probability. Okay, that's obviously 0. And I copy this down. And now take a look here, the sum of all those values, that is 2. So, because the average is essentially written as x bar equals, okay, so what did we do? 0, well, let me remove here some of those. So we did 0. This looks big. So we did 0.05 times 0 plus 0.26 times 1 plus 0.40 times 2 plus 0.24 times 3 and so on. And that is the average. And that average is 2. So what value is 2? 8 over 20? No. 5 times 8, that's 40 over 20, so that's 2. 8 times 5, that's 40, no. 5 times 5 over 2, no, that's something 0 point. So it must be B. And it looks like that the formula is something like the sample size over the number of successes in the bowl actually I have to, the number of successes still goes in the numerator. Hold on. So the sample size times the number of successes over the total elements in bowl. Okay, so our sample size is 5 times 8, 40 over the sample size, over the total number of elements, 20, that was the 2. Okay, which Excel function computes negative binomial distribution? Okay, that's obviously nec_bin. In nec binom.dist, what does the f parameter represent? Well, that's the number of failures before you get to the number of successes. We can always double check with Excel. We can delete this again. So nec binom.dist. You see number f. You can even click on it. Well, it's the number of failures. So the probability, the number of failures before the rth success, that's correct. The geometric distribution is a special case of the negative binomial distribution where p equals 0.5. The number of required successes is equal to 1. Sampling is without replacement. Lambda equals 1. So the geometric distribution is, no, it can't be 0.5 because probability could be anything. Then lambda equals 1, that refers to the Poisson distribution, but the negative binomial distribution is related to the geometric distribution, that it is sampling without replacement. The number of required successes is not 1. Okay. But that's maybe a bad question, we should take that out. The Poisson distribution is most appropriate when sampling without replacement? No. That would be hypergeometric. Counting rare events over continuous intervals over time or space. That's exactly what it is. A quality inspector selects 5 items from a batch of 20 items, of which 4 are defective. Which distribution is appropriate to model the number of defective items in the sample? Okay, so we essentially draw from a bowl, so it must be hypergeometric. And we draw from a bowl without replacement, obviously. Okay, you use 1 minus Poisson Dist4 3 true in Excel. So this computes. Okay, if you just take a look at Poisson Dist 4.3 true, what do we get? Equals Poisson dot dist, and then we get 4 events when the average is 3, and it's cumulatively. Now there's obviously a typo. Poisson. Okay, so this is the probability that we either get no event, 1 event, 2 events, or 3 events, or 4 events. So the remaining roughly 18% or so, that must be the probability that you get 5 or more events. So B is correct. Okay, in hypergeometric distribution, xn, kn, cumulative, what does the parameter k represent? That is the number of successes in the sample. And again, we can double check with Excel. We just call hypergeometric distribution, and then we want the third element, 1, 2, 3. So that's the population successes. So that is C. Okay, if you compute neg binom.dist 320.5 true in Excel. Okay, so the critical element is again the true. That calls for a cumulative, and that means we get at most 3 failures before we get 2 successes. That's what it is. So we have at most 3 failures before we get 2 successes. A lot of 25 light bulbs contains 5 defective ones. A sample of 8 is drawn without replacement. Okay, good thing is we immediately know that this calls for the hypergeometric. So there are 2 choices, B and D. So it would be written correctly in Excel. Okay, a sample of 8 gives that we get exactly 1 is defective. 1. Our sample size is 8. And the total number of defectives is 5, so that is like the successes in the bowl. And we have a total of 25 light bulbs. And we want to know that exactly 1, so that rules out 0 or 1. So that means we have to make that a 0. It's like a 35% chance. A factory produces an average of 2 defects per 100 meters of fabric. Okay, so those are rare events per interval, like a space interval, and that calls for Poisson. And of course, the person who came up with those questions figured that out too, obviously. So which one is the correct Poisson formula? What Excel formula gives the probability of finding exactly 5 defects in 200 meters? Okay, so what we can do is, because we have only information of 2 defects per 100 meters, but if I want to know what happens in 200 meters, I can prorate the average by 2, and then we can look at the probability of getting 5 per, when the average is now 4. So yeah, the mean can be prorated. Okay, in Excel, which function calculates the probability that the Poisson random variable x equals exactly 2 given lambda 5? Okay, that can only be B. So Poisson, exactly 2 successes, the mean is 5, and the false indicates not cumulative. A committee of 3 is randomly chosen from 5 Democrats and 6 Republicans. To find the probability of exactly 2 Democrats on the committee, you should use, okay, it's drawing with replacement, so it must be the hypergeometric one. Okay, I think by now it should be clear. A basketball player has a 70% free throw success rate. You want to find the probability that his 5th successful free throw occurs on exactly his 8th attempt. So that means we want to know the probability that that he scores or he hits exactly on the 8th attempt the 5th time. So the 5th successful free throw occurs on the 8th. So that implies that on 3 he missed 3 before. It could be the first 3. So let's say if the player misses the first 3, 1, 2, 3 are misses, then 1, 2, 3, 4, 5. So that's another 5 hits in a row. And that is, of course, the negative binomial. If you want to know what the probability is, we would say equals neg binom disc number of failures 3, and then the number of successes 5. The basketball player has a free throw percentage of 0.7, and it's exactly, so it is a 0, so it's a 15% chance. A salesperson makes calls until she closes 3 sales. Okay, the probability of closing each call is 0.4. Which distribution models the total number of calls she needs to make? Okay, so that is basically also the negative binomial, because before she makes 3 sales in a call, there's a certain number of calls that fail or do not translate into a sale. So it's concerned with failures until you obtain a certain number of successes. If p equals 0.1 and n equals 5, then the corresponding binomial distribution is, okay, right skewed. So why would that be? Because if the success probability is 0.1 and we have 5 trials, it could be that we don't get any success, or 1 or 2 or 3 or 4 or 5. So if the success probability is 0.1, so that means we will have the highest peak down here, that barely any successes happen, so 0 or 1, but then it fiddles out, so it's skewed to the right. Now if you want to, we can quickly simulate that again in Excel. Let's do it for 10, actually we do 5 successes. So 0, 1, 2, 3, 4, 5. Probability. And I do that as a function of a p that you can choose, so let's say 0.1. Okay. So this is something you can enter or choose, and then we would use the binomial distribution. Binom.dist. Okay, trials 5. Success probability 0.1, that's a given now. And we don't want it cumulatively, 0. Okay, so this is what it looks like, so we can draw it. Insert. And you can see it is skewed to the right. Actually, let's quickly. And if you had like 0.5, it would be symmetric. And if you had 0.9, it would be skewed to the left. Which of the following is a valid probability for a discrete random variable? Of course, that must be 0.2. A deck of 52 cards contains 13 hearts, and if 5 cards are drawn without replacement, which Excel formula gives the probability of drawing exactly 2 hearts? It's obviously the hypergeometric. Question is just which one. So in this case it is A. So what does that formula say? Equals hypergeom dist. Okay. So in the sample we want to have 2 hearts, so that is our sample successes. How many cards do we draw? 5. How many hearts are in there? 13. How many cards do we have in total? 52. And then we don't want it cumulatively, up to 2, exactly 2, so 0. So that probability would be 27%. A random variable is said to be discrete if its outcome is countable. That's correct. Because continuous variables, they are measured. Discrete variables are counted. A fair die is rolled 10 times. What's the probability that an odd number will occur less than 3 times? Okay, so that's again the binomial. So less than 3 times, so we have 3 number of successes, but it's cumulative in 10 trials. Success probability is 0.5, but now it is cumulative. So that's 17%. Well, which we don't see here, so I must have made a mistake. Oh, less than 3 times, so we have to, it's not 3 or less than 3 is 2. So now we have 5%. Okay, in the most recent election, 19% of all eligible students voted. If a random sample of 20 students were surveyed, find the probability that exactly half, which is 10, voted. Okay, so we assume that the probability is still 19%, so we would say equals binom.dist, number of successes 10, trials 20, so we randomly select 10 people. The success probability is 0.19, and it's not cumulative because exactly 10. So that's a pretty small number. For a Poisson random variable x with parameter lambda equals 4, what is the mean of x? Okay, so, well, lambda is the mean. So that's 4. And that is also equal to the variance. So the variance is equal to the square root of lambda. A server crashes on average 1.5 times per week. Using Excel's Poisson dist 0, 1.5 false formula, what probability is being calculated? The probability that the server crashes exactly once, at most 0. That's the same even if it's false, because we can take that cumulatively. So it's the cumulative probability of at most 0 crashes. The mean of the binomial distribution, well, that's the number of events times the probability. Which of the following statements about the binomial distribution is not correct? Each trial results in a success or failure. No, that's correct. Trials are independent of each other. No, that's correct. The probability of success remains constant. That's correct. So it's not a continuous variable because we count it. Which distribution applies when first trials are fixed, each trial is independent, 2 outcomes exist, and the probability is constant? Well, that's the binomial too. All right. So I think it was pretty repetitive, but I think you have developed now really some good feeling for the nature of various distributions, and let's just stop here.